This meeting is being recorded.
So when we looked at problem 1 from chapter 8, we were dealing with nomenclature, as we will also be doing with problem 8.2, but we're going to be working kind of in reverse. We were given a structure, if you recall, if you looked at the problem 8.1, so we were given a structure and asked to provide the systematic name, so the IUPAC nomenclature. So now we're going to be given that nomenclature and asked to draw the structures, draw the compounds. So for 8A here, we'll start with that one. We have 3-isopropyl, 2,4-dimethyl-2-pentene. So just like when we're working the other way, we start with the identification of the parent. So we'll also start with drawing our parent, right? So we need 5 carbons, so 1, 2, 3, 4, 5. All right, and remember we always do that zigzag approach here when we're drawing carbons in a chain. We're also told that it's a 2-pentene, so I know to put my double bond between my carbon 1, my carbon 2 and 3 rather. So I'm going to put that double bond right here. So we have a 2-pentene so far. Now we need to incorporate that 3-isopropyl. Right, so that's our first substituent that's named. So I'm going to draw an isopropyl functional group, or an isopropyl substituent rather, coming off the side here. And we have also to name to draw the 2 and the 4 substituent, and they're both methyl substituents. So on my carbon 2, I'll place just one line coming out like that. So that's a methyl group, a methyl substituent, and then we have another on our carbon 4. So that's how I would approach A here. We can also look at the molecule B. So this will be B over here. We'll do that one in purple. And we have a 4-ethyl 2-methyl 2-hexene. So again, we'll start with our parent. So 1, 2, 3, 4, 5, 6 carbons in my longest chain now. I have my locant of my double bond, so my hexene, it's a 2-hexene, so 1, 2, so it'll be a double bond here between the carbon, right, 2 and 3, just like before. The last molecule had a 2-pentene, now we have a 2-hexene. And let's go back and let's look at these 2 substituents. So we have 4-ethyl, so on my carbon 4, I'm going to have an ethyl substituent, right? So we have 1, 2 carbons here, and then on my carbon 2, I'm going to have a methyl substituent, so we'll just draw a single line coming down like that. So this is 4-ethyl 2-methyl hexene. And while we're here, let's take a look at C. So C is a little different. We have a cyclo structure in the name. So we don't need a locant to specify the position, because we assume that it's between the carbon 1 and carbon 2 when we have a cyclic structure. So let's draw what would cyclobutane be, right? So our cyclic alkane with 4 carbons would be a cyclobutane. But since this is cyclobutene, we just have to add a double bond to one of those 4 sides. So now we have our parent, the cyclobutene, and now we just need to add on our substituents. So if the double bond is between carbon 1 and 2, we need a dimethyl, or 2 methyl substituents, 1 on carbon 1 and 1 on carbon 2. So this would be our 1,2-dimethyl cyclobutene.